Hello and welcome to yet another thrilling installment of the Algebra 1 videos. This is Unit 4 and this is Section 4 and this is graphing two-variable linear inequalities. What we want to do is we want to relate the graph of a two-variable inequality to its algebraic representation. So what we do is we take these inequalities, okay, what we want to do is we want to graph the boundary line using the related equation. Okay, here's the boundary line, or here's the boundary line. And then we want to test a point that is not on the boundary line of the inequality to see what happens, to see where a solution set is. And we want to shade above or below the line. So want to make sure that we put in here that the shaded region represents the points in the solution set, so points that make that inequality true. A solid boundary line means that the points on the line are included in the solution set, and a dashed boundary line means that the points on the line are not included in the solution set. So what I want to do is come around here and I want to show you, this picture right here. We want to determine whether the point is a solution to the inequality. So here's our inequality, okay, and we've got the line y is less than or equal to 1/2 x plus 1, okay? And so what we've done is we've gone ahead, we've graphed the line, this line right here is the line y equals 1/2 x plus 1, okay? It's got a y-intercept of 1 and we have a slope of 1/2, so we got to be able to graph the lines, okay? It is a solid line. Okay, it's a solid line because we have the greater than or less than or equal to symbol, okay? So what I want to do is I want to plot these points on the graph and see if they are a solution to the inequality, okay? And so if I plot the point, say -2, -1, this point is right here, -2, -2, 1 is this point right here. Okay, because it is not in the shaded region, this is not a solution. So no, okay, not a solution. Okay, the point 2, 2, all right, is right here, okay, and that is on the boundary line that is solid. Okay, so we include that line, we include the points that are actually on that line. So yes, this does satisfy the inequality. The point 2, 3 is up here, okay, and no, that does not satisfy because it is not in our in the shaded region. And then the point 4, 2 is here, and that point is in the shaded region. Okay, so yes. All right, so what I quickly want to do is I just want to test some points real quick just to show you. We can look at this graphically. It's pretty easy to tell if points are solutions to this are in the solution set, but let's take a look at and let's test some points. So my x value, let's test a point that was yes. So let's test, say, the point 4, 2. So x equals 4 and y is equal to 2, okay? And so y is equal to 2. I'm going to plug it into my inequality here, okay? And so I've got 2 is less than or equal to 1/2 times 4 plus 1. So 2 is less than or equal to 1/2 times 4 is just going to give me 2, so 2 plus 1. So we get the inequality that 2 is less than or equal to 3, okay? And this is a true statement, and so it was in our solution set, okay? Now if I test another point, let's say I test like the point 2, 3 here. If I let x equal 2 and y is equal to 3, then I test that and I get that 3 is less than or equal to 1/2 times 2 and then plus 1, okay? And so I get 3 is less than or equal to 1/2 times 2 is just going to give me 1. So this is 1 plus 1, so 3 is less than or equal to 2. And this is a false statement, okay? 3 is not smaller than 2. And that's why we said no, okay? So true means that that point will be in the solution set, and false means that it won't, okay? And so we're just trying to, graph these and see what we get, okay? Over here, kind of the same thing. It says determine which points are in the solution set of the given inequality, then write a linear inequality that satisfies all of the points on the table. Okay, so what I want to do is take a look at these points. And if I plot the point negative 2, 1, okay, that's going to be right here. Okay, and yes, this is in our solution set. The point 2, 2, okay, is on the dotted line, and that is a no. It is not part of our solution set. Okay, the point 2, 3 is up here, and that is in the shaded region, so yes. And then the point 4, 2 is here, okay, and it's not even in the shaded region, so that's no. Okay, notice how on this one, okay, we had just y is greater than 1/2 x plus 1. Okay, that's our inequality. And because we have a dotted line, okay, that's a dotted line, that's because of the just strictly less than, or y is greater than 1/2 x plus 1. So, and so that's just something that we got to keep in mind. Okay, we do not include the values in the solution set that are actually on the dotted line themselves. Okay, so that's that. All right, so now let's take a look and let's actually do this. Let's actually graph the inequality. Okay, so the first thing I want to do is I want to graph the boundary line using the related equation. So, you know, given the inequality like this, let's write it as the equation y equals 3x minus 5, okay? Now, we want to use a solid line for less than or equal to or greater than or equal to. So because this is greater than or equal to, we want to put we want a solid line, okay? We would use a dashed line for the others. Okay, so here, you know, let's just make sure we know how to graph this line. Okay, I have a slope of 3 and a y-intercept of negative 5, okay? So I'm going to come down to negative 5, plot that point. Okay, I'm going to go up 3 over 1, so up 1, 2, 3 over 1. Okay, plot a point. All right, go up 1, 2, 3 over 1, plot a point here. Okay, up 3 over 1, and so on. Okay, and then I connect those points with a line, okay, and it's a solid line. Now what I want to do is I want to test a point that is not on the boundary line of the inequality. The easiest point to test, so I always test the point 0, 0, okay? I try and test this point here, okay? If it's true, then I shade above the line, okay? But if it's false, okay, if I plug that into my inequality, then I shade on the other side. So let's test that. So I'm going to do 0 is greater than or equal to 3 times 0 minus 5, okay? And so 3 times 0 is just going to give me 0, so I end up getting the inequality 0 is greater than or equal to negative 5. So this is true, okay? And so because that's true, I want to shade where that point was. This is the point that I tested, okay? It was true, so I'm going to shade above that line, and that's where I have my solution set, okay? And that's the idea. Just use your pencil and shade. Doesn't have to be very specific, but, you know, the better the shading, the better, okay? So that's it. So any point that's inside of this shaded region will satisfy and make this inequality true, okay? Any other point that's not in that shaded region will make this inequality false, okay? So now let's take a look at the next one, okay? Let's use this, graph the solution set for this inequality. The first thing I want to do is write the equation y equals negative 2x minus 1. So I have a slope of negative 2. I have a y-intercept of negative 1. So here's negative 1, and we have a slope of negative 2. So it's going to go this direction, slope of 2. So I'm going to plot these points down 2 over 1, down 2 over 1, up 2 to the left 1, up 2 to the left 1, and so on. Okay, but I want to make sure that I'm using a dotted line, okay, because we are simply, y is just less than negative 2x, okay? Because this doesn't have an equal sign, we have to use a dotted line. So a dash, we'll use a dashed line, okay? And that's because of my inequality, all right? So now what we want to do is so we've graphed that boundary line. Okay, now we want to test a point that is not on the boundary line. I'm still going to test the point 0, 0. Okay, that's not on the boundary line. That's good. You can pick any point you want, but that's the easiest one. Okay, and that's going to be above the line. Okay, just barely. All right, so I'm going to plug that in, and we're going to get 0 is less than negative 2 times 0 minus 1, okay? So 0 is less than, okay, negative 2 times 0 is just 0, so it's less than negative 1. Okay, so that's saying that the larger number is negative 1, and this is a false statement, okay? So because the point 0, 0 was false, we shade on the opposite side. So we shade opposite of the point, okay? Shade opposite. All right, so I'm going to come over here, and I'm going to come here, and I'm going to shade below the line, okay? And that's where my solution set is going to be, okay? Okay, let's take a look at the next page. What I want to do is I want to graph the solution set for this inequality. And in this inequality, I don't really like this one that much. Let's change this into slope-intercept form and solve this for y. So I'm going to subtract 3x from both sides. And it's going to give me that 2y is less than negative 3x plus 6. I'm going to divide by 2, divide by 2, divide by 2. So I get that y is less than negative 3 halves x plus 3. Okay, so this is going to be, because of my inequality, my line is going to be dashed, okay? I need to think of my actual equation here, and that's going to be y is equal to negative 3 halves x plus 3. So our slope m is negative 3 halves. Our y-intercept is a value of 3. So I'm going to come over here, I'm going to graph this. So I've got y-intercept of 3. And I have a slope of negative 3 halves. So I'm going to go down 3 over 2. Okay, down 3 over 2, down 3 over 2, and then up 3 over 2. All right. And so then I use a dashed line to go across here. Okay. And then I want to test the point 0, 0. So I'm going to test the point 0, 0 in our inequality. Now you can either plug it into this inequality down here, or we can plug it into the original equality. Let's just do the original equality because it's really not going to, it's going to be a little bit easier for us. So I'm going to do 3 times 0 plus 2 times 0. Is that larger or is it smaller than 6? Okay, 3 times 0 is 0, plus 2 times 0 is less than 6. So I get 0 is less than 6, which is a true statement. Okay, so because I tested the point 0, 0, and it was true, then I'm going to shade in that region that had the point 0, 0. All right? And that's where we shade, okay? Strictly because we had that point 0, 0, and that makes it true. Okay, let's take a look at this next one. Now, on this one, it gives us the actual inequality that we want to represent the graph. So what I want to do, this is a little bit trickier. So let's kind of think about something here. Let's think about the y-intercept. Okay, let's find the y-intercept. That looks like I have a b value, a y-intercept, at positive 3.5. So you can write 3.5, or you could even write 7 halves. You can write the fraction down, doesn't matter. Okay, but going from one point to the next, okay, my slope, you know, if I make a stair step here, you know, my slope here is going to be down 1 to the right 2. So my slope m is going to be negative 1/2. All right. So now what I want to do is this. I realize, okay, so I can write my equation. Okay, if I just think of my equation, y is equal to negative 1/2 x plus 7 halves. Okay, so there's my equation, okay, that represents this line. Okay, but we need to figure out, okay, what would happen, you know, where do we shade? Do we shade above or below? Since we shade above, the point 0, 0, okay, 0, 0 makes the inequality false, makes inequality false. Okay, so what I want to do is this. I'm going to plug in 0, 0 into this. I'm going to go 0 is equal to negative 1/2 times 0 plus 7 halves. Okay, so then what happens is I get this statement. This part just becomes 0, and I get that 0 is equal to 7 halves. Now, in order to make an inequality false here, I would have to say that this is larger than this. Okay, I want to make false. Want to make it false. So what I need to do is say, okay, what inequality could I make with 0 and 7/2 in order to make it false? And if I said that 0 was greater than or equal to 7/2, this is a false statement. So that helps me write my inequality and helps me say, all right, well, if I just take this and I write y is greater than or equal to -1/2 x and then plus 7/2, this is the answer that I'm looking for, okay? You may need to put that into standard form, but, you know, right now, slope-intercept is just right fine. So I hope this wasn't too bad for you. It's kind of a process to do it, but as long as you follow this process, guys, it's always going to work. So hope you enjoyed the video, and I'll talk to you later. See you. Bye!